So for the backside, numbers 21 through 30, I already did number 21 in class. And then, so what we did was when we realized that we have three zeros here, 0, -3, and 1, if 0 is a 0, that means that x minus 0 is a factor. -3 is a 0, x minus -3, or x plus 3 is a factor. And then if 1 is a 0, then that means that x minus 1 is a factor of the polynomial. So that's how we set it up, and then the way we draw the graph is that we realize that if 0, 1, and 3 are the x-intercepts, which is why they're called zeros, then the graph will hit the x-axis at those 3 points. Since each one of those factors has a multiplicity only of 1, it means that the graph of the function goes through the x-axis at each of those x-intercepts. Goes through, crosses it without a squiggly, just goes straight through. And we know that the graph of the third-degree polynomial looks like this, goes up from left to right. When you multiply the 3 degrees, we get x times x times x is x to the third. That's why we know it's a third-degree polynomial. So it has to look like this. It has to start low, go through the x-axis at -3, through at 0, and through at 1. So we look at number 22 and we identify the 3 zeros. We put a dot on the x-axis at 0, 1, and 4, and we realize that each of the multiplicities of the factors is 1. So therefore we draw the graph. Again, it's third-degree polynomial, so it's going to go up through 0, come down through 1, and then go up through 4, and we have our rough sketch of our polynomial function. So for number 23, let's see here. Number 23, we see that the x-intercept of 1 has a multiplicity of 2. The x-intercept of 3 has a multiplicity of 1. So we've got the factors, and we put the dots on the x-axis. Now, we still have a third-degree polynomial, so the graph is going to go up from left to right. So we still do that, but we realize that since a multiplicity of 2, the graph is going to just touch the x-axis at 1 and then go up through the x-axis at 3. Okay, likewise over here we have a third-degree polynomial. This is really no different than the ones that we've already done, -1, -4, as well as +4. And we have a third-degree polynomial. We're going to go up through the graph at -4, down through it through the x-axis at -1, and up through the x-axis at 4. We're not really concerned about how high or low these polynomial graphs are going. We just really want to make sure we get the graph above the x-axis where it's supposed to be, below it where it's supposed to be, and then the behavior at each of those x-intercepts is a key feature of these graphs. So likewise over here now we have a fourth-degree polynomial. We equate the zeros at -5, -2, 5, and 0 to the factors of x minus 0, x minus -5, x minus -2, and x minus 5. And then we put dots at each of those zeros, -5, -2, 0, and 5. And then we draw the graph. Well, we know the graph is going to be a fourth-degree polynomial, and so it's going to go up from left to right. We have a double root. No, we don't have any double roots at all. So we're just going to come down through the x-axis at -5, back up through at -2, back down through at 0, and then back up through at 5. Okay, let's see how we do numbers 26 through 30 here. Kind of lost my train of thought there. Sorry. Actually, I'm at 4 minutes now. I'll do the other 5 on a second video.